And I want to talk about a statement that you made. This is a great jumping off point. In the nutritional guidelines, somebody said, saturated fat is not required in the human diet. I want to talk about why that statement is misleading and potentially very, very wrong. So in our body, there is something called de novo lipogenesis, whereby our body makes fat, but our body makes saturated fat. So this, again, just doesn't really make a whole lot of sense from the Ansel Keys perspective. Your body, my body, every single body makes palmitic acid in the body. We make stearic acid. Well, I don't know if we make stearic, but we make a 16 chain or an 18 chain, palmitic acid in the human body. That is de novo lipogenesis. We make this. Why would our bodies make something that is so bad for us? And then our bodies have an enzyme, which is called SCD1, steroyl-CoA desaturase. It's a delta 9 desaturase, and I'll talk about why that enzyme is so important. That turns that saturated fatty acid, that turns that palmitic acid to palmitoleic acid. It turns into a monounsaturated fatty acid. And that ratio between palmitic and palmitoleic acid is very, very important. And this is where PUFAs come into play. The human body does not make polyunsaturated fatty acids, ever. We don't make it. So all of the polyunsaturated fatty acids in our body are from our diet, and this is what's so concerning to me about polyunsaturated vegetable oil, is that essentially we are a gas tank, and all of our body will store the oils that we eat. So if you drink corn oil, or you are taking 2 tablespoons or 4 tablespoons of corn oil every day in your diet, you are storing that corn oil in your cells. And that corn oil, that polyunsaturated PUFA is eventually going to get oxidized in a process called beta oxidation. But remember, that is linoleic acid, which looks very different than stearic or palmitic acid because it is a polyunsaturated fatty acid. Oleic acid and palmitoleic acid are monounsaturated fatty acids. So the way they go through beta oxidation is very importantly different. But this is the point that I made earlier, that evolutionarily, humans have only ever seen very, very low amounts of polyunsaturated fatty acids in our diet because wild animals don't have polyunsaturated fatty acids to the level that domesticated animals do. I want to share this because I think it's super fascinating. The fatty acid content in chicken thigh and breast as affected by dietary polyunsaturation level. Basically, this study says that if you feed a chicken corn, it will have way more polyunsaturated fatty acid in its diet, in its body, than a wild bird. Okay, so basically, chickens fed corn are like a synthetic or a sneaky source of vegetable oil. So people might be listening to this and thinking, I don't drink vegetable oil, but if you're eating mainstream chicken that's fed corn, you are getting linoleic acid in this way. And I'll tell you why this is a big deal in a moment. The other thing I want to highlight here is that we see the same thing in pork. The fatty acid content from pork is the same thing. The effect of dietary mono and polyunsaturated fatty acids on the fatty acid composition of pigs' adipose tissues. The takeaway here is that if you feed a pig corn or you feed a pig soybeans, their fat is going to be very PUFA, polyunsaturated fatty acid enriched. And again, if we are eating animal foods that have higher concentrations of polyunsaturated fatty acids than our human biology is expecting, things go awry very, very badly. And this is why. Because humans don't make polyunsaturated fatty acids. And because of the way that beta oxidation of these polyunsaturated fatty acids happens, it can affect the insulin sensitivity of the adipocyte. You guys better buckle up because this is about to get a little bit crazy, I'm telling you. I did an Instagram on this on Saturday morning. So if you want to rewatch it, you can rewatch that as well. But I want us to talk about this as a really interesting theory. And this is why saturated fatty acids are absolutely invaluable to human health. So check this out. If you guys have seen beta oxidation, this is the process of breaking down long-chain fatty acids into short-chain fatty acids to be used for energy within your mitochondria. The takeaway from this is that as a fatty acid is broken down in beta oxidation, FADH2 and NADH2 are produced. But the very important piece here is that when you break down polyunsaturated fatty acids or monounsaturated fatty acids, they have a different ratio of FADH2 to NADH2. Paul, why are you telling us all this? Because that ratio of FADH2 to to NADH2 determines whether your adipocyte is going to be insulin sensitive or insulin resistant. And this is where things get a little complicated. So bear with me here, you guys. You want your fat cells, so this is the fat cells in your belly. You want your fat cells to be insulin resistant, because when insulin binds to the surface of an adipocyte, that is going to trigger, if that fat cell is insulin sensitive, that fat cell will take up glucose and will take up lipids via lipoprotein lipase, and that fat cell will grow. You want your fat cells to be insulin resistant. And the way you get fat cells that are insulin resistant is by eating saturated fat. And this has been shown time and time again, that if you increase the amount of palmitic acid and stearic acid in the diet, your fat cells become insulin resistant, which means that when insulin spikes with a meal and insulin signals to those adipocytes to grow, they won't respond. Those adipocytes won't take up glucose and they won't take up lipids and become bigger fat cells. What I am saying here, guys, is that suet from animals is a fat burner. Suet from animals is a fire starter. If you eat a diet that is higher in stearic acid and palmitic acid, you will lose weight because it is telling your fat cells to be insulin resistant. You don't want your fat cells to be insulin sensitive. Now, because, and this is where things get a little bit shaky, so bear with me, because of the different structure of the polyunsaturated fatty acids in beta oxidation and that changing ratio of FADH2 to NADH2, your fat cells become insulin sensitive when you eat polyunsaturated fatty acids. It breaks your metabolism. And insulin sensitive fat cells equal fat cells that are growing and getting bigger. And fat cells that are getting bigger means fat people. So if you want to get fat, eat polyunsaturated fatty acids because they have a unique signal to your abdominal adipocytes to make them more insulin sensitive. Now, finish the story here. As the fat cell expands, right, it sends out free fatty acids to the rest of the body. And the signals from that fat cell are called lipokines. I'm going to do a whole podcast about this in the future, you guys. As your fat cells grow, they send out free fatty acids to the rest of the body. And those free fatty acids from the fat cells tell the rest of the body whether it should be insulin sensitive or insulin resistant. And those free fatty acids are what determine what is going on.